Today, we're going to be looking at parallel line proofs. So proofs involving parallel lines. We might be given a set of parallel lines and asked to prove some relationships between angle measures, or we might be asked to prove two lines are parallel. Now, proofs are really difficult, so the proofs in this lesson are going to be partially filled in. Some statements will be filled in on the left, and we're asked to find the reason. Some reasons will be filled in on the right, and we're asked to find the statement. And just a reminder, some helpful tips whenever you are filling out a proof. What you're given is always going to be the first statement, okay? You can have multiple givens in a proof, and given is the reason, right? So what you're given is the statement, given is the reason. What you are proving is always going to be your last statement. You're going to write the justifications for each step in the reasons column, and you can refer to your reason bank. And when you're asked to prove a theorem, you can't use the theorem in your proof. We will be proving and using theorems. In our first example, we're going to prove the alternate interior angles theorem. So we can't actually use this reason in our proof. But we are going to use the corresponding angles postulate and the vertical angles theorem in this proof to prove the alternate interior angles theorem. We are given that line M is parallel to line N, and that's our first statement. Given is already the reason. The next statement is given for you. Angle 1 is congruent to angle 3. Well, how are those angles related? They're corresponding angles. What is it that tells us angle 1 is congruent to angle 3? The corresponding angles postulate. Then number 3, the reason is the vertical angles theorem. Okay, well, that theorem tells us that vertical angles are congruent. The only vertical angles I'm given in this figure is angle 3 and angle 2. So my statement can be angle 2 is congruent to angle 3. And then because this proof is written the way that it is, or, I have like boxes and numbers, that step number 4, statement number 4 is going to be your last statement. And that's going to be what you're asked to prove, which is angle 1 is congruent to angle 2. And those are alternate interior angles, right? But what did we do to get to this point? What's our reason? Well, I've got angle. Let's look at our previous statements. How can we conclude this right here from what we've already written? Angle 1 is congruent to angle 3. Angle 2 is also congruent to angle 3. If these angles are congruent to the same angle, then they are congruent to each other by the transitive property of congruence. Let's move on. In example number 2, we're going to prove another theorem. We're going to prove the same side interior angles theorem, and we're going to use the alternate interior angles theorem as a reason to show two alternate interior angles from parallel lines are congruent. Now, I've actually seen this proof written differently with maybe not so many steps, and I kind of like that shortened version better, but I also like this one. If you can just kind of like, it's all a thought process, right? Each statement, like what logically makes sense to go from each statement to the next. And so let's see if we can make sense of all of this. Number 1, given is already the reason. What we're given is line B is parallel to line C. The next statement says angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3. Well, I can't use the same side interior angles theorem in this proof, but I can use the previous theorem that we just went through, and that is the alternate interior angles theorem. That tells us alternate interior angles are congruent. So we're given parallel lines, and I know alternate interior angles are congruent. Let's use that theorem as a reason to show those angles are congruent. Now, the reason number 3 says definition of congruent angles. Well, congruent angles have the same angle measure. So I can say angle 1 is congruent to angle 4, and I can get that the measure of angle 1 is equal to the measure of angle 4. Now, our next statement is angle 1 and angle 3 form a linear pair, and angle 2 and angle 4 form a linear pair. Okay, well, that is the definition of a linear pair, right? I've got angles on the same line, okay? And angle 1 and angle 3 are supplementary, and angle 2 and angle 4 are supplementary. Well, that's the linear pair theorem that tells us that, right? Angles that form a linear pair are supplementary. So I've identified, okay, they form a linear pair. That's the definition, by a definition of a linear pair. And then the linear pair theorem tells me, okay, they're supplementary, right? Now, from there, I can move on to the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Well, that's the definition of supplementary angles, right? So if angles are supplementary, then when I add their angle measures together, I get 180 degrees. That's the definition of supplementary angles. So, statement number 7, I know it's going to be our last statement. Well, that's what we're going to be asked to prove, which is the measure of angle 1 plus the measure of angle 2 equals 180 degrees. How do I get to this point? Let's see here. The measure of angle 1 plus the measure of angle 2. Well, what have I previously? Okay, I've got this equation right here, measure of angle 1 plus the measure of angle 3, and the measure of angle 2 plus the measure of angle 4. Okay, how did I get from there to here? Well, if you look up here previously, I've shown the measure of angle 2 equals the measure of angle 3. If that's the case, can I substitute the measure of angle 2 for the measure of angle 3 in this equation? Sure. I'm just going to use the substitution property of equality, or you could just write substitution there. So that's all I did, because, and you have to have previously written it down in a statement to be able to do that in your last statement. Now let's look at example number 3. We are going to be proving the converse of the alternate exterior angles theorem. And we're going to use the converse of the corresponding angles postulate and the vertical angles theorem to prove that alternate interior angle theorem's converse, which that might be how you see it, the alternate interior angle theorem's converse, or the converse of the alternate exterior angles theorem. You know what? This says alternate exterior angles, and this is alternate interior angles theorem. This should say exterior, so I'm going to fix that. It should be fixed on your notes as you watch this. So we are given angle 1 is congruent to angle 3. So that's going to be my first statement with what as my reason? Given. Then I've got angle 2 is congruent to angle 3 as a statement. How can I conclude that? What is it that tells me angle 2 is congruent to angle 3? The vertical angles theorem. Then I've got angle 1 is congruent to angle 2. Well, okay, angle 1 is congruent to angle 2. Well, how do I get that? Angle 1 is congruent to angle 2. So if up here I'm given angle 1 is congruent to angle 3, and I know angle 2 is congruent to angle 3. So I know angle 1 is congruent to angle 2 by the transitive property of congruence, right? These two angles are congruent to the same angle, so they are congruent to each other. Then I can conclude that M is parallel to N by the what? Converse of the corresponding angles postulate. And that should say that. Converse of the corresponding angles postulate. This right here, let me see if I can fix it. This should say, this is postulates converse. Okay, so make sure you write that down. Corresponding angles postulates converse, right? Because we're proving lines are parallel. So we need to use the converse of the corresponding angles postulate. Let's move on to example number 4. We are given that line X is parallel to line Y. We're also given that angle 1 is congruent to angle 2. We're asked to prove line C is parallel to line D. Well, let's start with what we're given. We're given that line X is parallel to line Y. And again, because this proof is partially filled in, we're kind of given some clues throughout the process. Well, the corresponding angles postulate is our next reason. So what would be the statement that goes with that? The corresponding angles postulate tells us these corresponding angles are congruent, right? These are my parallel lines. That means line C is my transversal when it comes to these two angles, and I know they're congruent. So angle 1 is congruent to angle 3. The next statement says angle 1 is congruent to angle 2. Well, that was one of our givens, so I'm going to write given there. Then the next statement says angle 2 is congruent to angle 3. How do we get from all of this to that? Well, I've written angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2. And if two angles are congruent to the same angle, then they're congruent to each other by the transitive property of congruence. And I've stated angle 2 is congruent to angle 3. Well, if these two angle measures are congruent, they're along this line right here. That would make line X my transversal. And these are the two lines that transversal intersects. And those are alternate exterior angles. And if they're congruent and we're proving lines are parallel, then my reason would be the converse of the alternate exterior angles theorem. Let's move on to example number 5. We're given line X is parallel to line Y, and we're asked to prove that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Well, first let's start with what we're given. Line X is parallel to line Y. That's what we're given. The corresponding angles postulate. Okay, well, if these two lines are parallel, that would make line W the transversal. These are corresponding angles, and the postulate tells us they're congruent. So angle 1 is congruent to angle 2. Statement number 3 says the measure of angle 1 equals the measure of angle 2. Now, I know to maybe write the definition of a congruent angle when I'm asked to prove, and like I've got angle measures as what I've been asked to prove. So somehow I need to get to the fact that if these angles are congruent, then by the definition of congruent angles, I've got a statement in there that shows me that those angle measures are equal to one another. Then I've got the measure of angle 2 plus the measure of angle 3 equals 180 degrees, and I've got the linear pair theorem. What I want to point out is that in a previous proof, I wrote extra statements to get to this statement. Like I identified the linear pair, I said they were supplementary, and then by the definition of supplementary angles, I got to this point right here, all right? You don't always have to do that. You can just say, all right, linear pair theorem tells me these two angles that form a linear pair, when I add them together, I get 180 degrees. And I just want to point that out because I feel like it might make a little more sense to you. So the measure of angle 2 plus the measure of angle 3 is 180 degrees. I get that by the linear pair theorem. Now, I know that my last statement is the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Okay, and I've already got the reason there for you. I use the substitution property of equality, or just the substitution property, whatever you want to state. And I got that because I've already shown up here in the statement that the measure of angle 1 equals the measure of angle 2. So anywhere I see the measure of angle 2 in any equation, I can substitute the measure of angle 1 for it. Right here, I see the measure of angle 2, and here I substituted it for it, which is what we were asked to prove. Let's move on to example number 6. We're given angle 1 and angle 3 are supplementary, and we're asked to prove that M is parallel to N. So first, let's start with what we're given. We're given that angle 1 and angle 3 are supplementary. Now, the next statement says angle 2 and angle 3 are supplementary. What tells me that? The linear pair theorem. And on our previous example, I went ahead and used the reason linear pair theorem to show that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. I did that because of what we were asked to prove. And this one, I'm just going to stick to the angle 2 and angle 3 are supplementary. Okay, that's all the information I really need for this one. Then it says the congruent supplements theorem. Well, if angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, then congruent supplements theorem says if angles are supplementary to the same angle, then they are congruent to one another. So because angle 1 and 3 are supplementary and angle 2 and 3 are supplementary, then that means angle 1 is congruent to angle 2 by the congruent supplements theorem, which we have talked about in a previous lesson. So if angle 1 is congruent to angle 2, then by the converse of the corresponding angles postulate, I can conclude that line M is parallel to line N. And I'm going to use the converse of that corresponding angles postulate. Why? Because I'm proving lines are parallel. I'm given congruent angles, so I can conclude that the lines are parallel. Let's move on to example number 7. I'm given angle 1 is congruent to angle 8, and I'm asked to prove that angle 2 is congruent to angle 4. Okay, well, let's start with what we're given. Angle 1 is congruent to angle 8, and my reason is given. I can conclude, based on that, angle 1 is congruent to angle 8, that line B is parallel to line C. How? If angle 1 is congruent to angle 8, well, first let's identify what type of angles are those. They're alternate exterior angles. And if they're congruent, and I'm proving these lines are parallel, then I'm going to use the converse of the alternate, and that should say exterior angles theorem. Sorry about that. Let me write that down. Angle 1 and angle 8. This should say alternate exterior angles. Sorry about that. The converse of the alternate exterior angles theorem, because angle 1 and angle 8 are alternate exterior angles. My next statement is I can then, because I've proven these lines are parallel, then I can say, I conclude that angle 2 is congruent to angle 4 by the corresponding angles postulate. So I've already concluded that the lines are parallel. So I can then conclude that corresponding angles are congruent. Angle 2 is congruent to angle 4. Okay, moving on. Example number 8. I know it's a lot of proofs, but honestly, this is just one of those topics that the more you do, the better you get. And proofs are just tough. They're just tough. So in example number 8, we are given angle 1 is congruent to angle 4. And we're also given that angle 3 and angle 4 are supplementary. So we've got 8 steps here. We're asked to prove that A is parallel to B. So let's get started. Angle 1 is congruent to angle 4. That's a given, right? The next statement, I have that the measure of angle 1 equals the measure of angle 4. Okay, well, what would be my reason to have gotten from step 1 to step 2, or statement 1 to statement 2? That's the definition of congruent angles. And remember, when you're filling out your proofs, you can absolutely abbreviate like any symbol. You can replace it, like definition of congruent angles. You can write like DEF and then the congruent symbol and then angles, and that works. Reason number 3 is already given as a given. So then I'm going to write the next given statement, which was that angle 3 and angle 4 are supplementary. So I've got these 2 angles right here are supplementary. By the definition of supplementary angles, I get that their angle measures, when I add them together, the sum of those should equal 180 degrees. Okay, so I've now got measure of angle 1 equals the measure of angle 4, and I've got this equation right here. Using the substitution property of equality, I'm going to come up with another equation here. What do you think that's going to look like? What do you think I'm going to replace measure of angle 4 with? The measure of angle 1. So now I know the measure of angle 3 plus the measure of angle 1 should equal 180 degrees. Now, I got to start somewhere else, right? I'm proving A is parallel to B. I'm getting closer, right? I need two angles that have a relationship along this transversal that intersect. One angle needs to intersect one parallel line. The other angle needs to intersect the other parallel line. So I'm right here. I'm showing that the measure of angle 2 is equal to the measure of angle 3. How do I get that? The vertical angles theorem, right? Because those are vertical angles, so they're congruent, so their angle measures are equal to one another. Now, if the measure of angle 3 plus the measure of angle 1 is 180, and the measure of angle 2 equals the measure of angle 3, then anywhere I see the measure of angle 3, which is right here, I can replace it with the measure of angle 2 by the substitution property. So now I've created an equation that shows this angle measure and that angle measure are supplementary, right? Those angles are supplementary. So when I add their measures together, I get 180 degrees. And now I've got two angles that are specifically related to these two lines right here along that transversal. I can now conclude A is parallel to B by the converse of the same side interior angles theorem. Let's move on to example number 9. We're given that line W is parallel to line X. We're also given that angle 2 is congruent to angle 3. So let's start with what we're given. That line W is parallel to line X, which means if these two lines are parallel, then that means these two angles are corresponding, angle 1 and angle 2, and they're congruent by the corresponding angles postulate. Reason number 3 says given, so I'm going to go ahead and write the other thing that we were given, which was that angle 2 is congruent to angle 3. And then now I have the transitive property of congruence as my next reason. Okay, well, what should be my statement? If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then I can conclude angle 1 is congruent to angle 3 by the transitive property of congruence. So now I've got angle 1 is congruent to angle 3. Okay, that would make this right here, line X, my transversal. These two lines would be proven parallel because these are what type of angles? They're alternate exterior angles. If I'm proving lines are parallel, then I'm going to use the converse of the alternate. Oh my gosh, I did it again. The alternate exterior angles. Right here. The alternate exterior angles theorem. So I can conclude Y is parallel to Z by the converse of the alternate exterior angles, right? They're on the outside of those two parallel lines. And let's move on to our very last example. There's a lot going on here, and I just wanted to give you an example that was written like this, right? It looks a little different. I've got points, and my lines are labeled by 2 points on the line, okay? So it's the same thing, right? You can write line W, but you can also designate a line by line IE, which would be this one right here, IE. And then here's AD, line AD, and line IE. And we just want to make sure we can read what we're given. So we're given that line IE bisects angle BGH. So you have to know some vocabulary here. What does bisect mean? It means it splits it in half, right? Directly in half. So these two angle measures are congruent, or they're equal. So their angles are congruent. The next thing we're given is that line AD, which is right here, is parallel to line IE. We're given that information. We're asked to prove that angle 1 is congruent to angle 3. So there's a lot going on here. I've got the statements all written down for you because this is clearly a difficult proof. Let's see if we can come up with the reasons. So the first statement is that line IE bisects angle BGH. Well, that's what we're given. The next is that angle 1 is congruent to angle 2. How do I get from this to that? How can I conclude that? Well, that's the definition of an angle bisector, right? It splits it in half, so you have two congruent angles. The next thing, statement number 3, reads that line AD is congruent to line IE, is parallel to line IE. Well, that's something we were given, right? So the next statement reads that angle 2 is congruent to angle 3. Well, if these two lines are parallel, and here's a transversal, then these two angles are corresponding. So their angles are congruent to one another by the corresponding angles postulate. Well, my last statement reads that angle 1 is congruent to angle 3. How do I get there? Well, if I look at previous statements, I have already written angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So I can then conclude angle 1 is congruent to angle 3 by the transitive property of congruence. And that concludes your very difficult lesson over parallel line proofs. I hope it was helpful.